I'm Mudit, the core contributor of Litmus. Yeah, today I'm going to share a new feature, or you can say a more of a demo packaged that Litmus has introduced. So it is actually a fully packaged demo in which you can run your first chaos. So what is demo environment here that we introduced in this release is the Litmus demo is actually a quick way to introduce yourself in the world of chaos native chaos engineering. So as we saw that some new members are here, so it might be helpful for them. So it helps familiarizing them to run Litmus chaos experiment in a realistic application environment. And you can say you can so what it will does that it will create everything for you. It will create a cluster for you, it will install application, and then it will subject uh, it will subject a chaos on the application, and you can even see that what effect you are getting on the application which is in the chaos. So everything you
Okay,
can
Udit. Yeah, sorry, I think the screen wasn't visible. Now it is. Thanks.
yeah okay. Okay, thanks Karthik. Yeah, so yeah, so moving forward, yeah, moving forward, I am having a demo. I will show you how you can run a Litmus demo in your system which require minimum dependencies. So I have a recorded demo for that. I will show you. So the first step is to just you have to go to our Litmus demo repository and just clone it to your local system. Once this Litmus demo repository comes to your Lego system, just enter in that and try running some commands, which will let you know that a list of experiments available. So here we need to have some experiment which is light. We need to have some way of creating cluster which is a lightweight and also sufficient, self-sufficient to perform all the operations. So we just can't think more than this kind of cluster, and so it is the best way. We also have a GKE support for running a larger suite of experiment. Uh, yeah. So you just need to add there is a one manage.py script. You just need to run it with the argument, some argument and some flags. So you just list. There are generally four arguments: run, start, list, stop. We'll get to that. We'll get back to that. So the list experiment will let you know the number of experiments or the name of experiments which are available for the particular platform. Like this sudo manage py list platform GK will give you the list of experiments available in GKE platform. So you can see there are 10 experiments available for running in GKE. So in kind also you'll support some main experiments. Yeah, the number is less, but that will be these are the core experiments that covers both infra and application level. And the default for everything, the default platform is set to kind. You don't have to mandatory giving it all the times. So it will all, if you just type the manage py.list, it will always give the values of kind clusters. So yeah, so we now came to know what experiments are available with us to run, and now we will start running that. So for starting our cluster, so we just need to run one single command. So you don't have to worry now here uh, to just go to the web documents and hub and everywhere. Although that way is also Litmus made it very simpler, but yeah, for the first time, if you are trying to use, you can just use it in this way only. What it will does that it will install everything for you. You don't need to have a cluster. A cluster will be created on that an application, shop application, which is actually a microservice architecture. It has and complete set of environment of whatever the chaos engine experiment, the RBAC, everything will be configured automatically, and you will just have to see what how your application is behaving in such a situation when it is under chaos. And So we can see that the script starts with installing a kind cluster, and what it will does, like it will create a 3 node cluster. It will take some few minutes, like 1 or 2 minutes. So everything is a matter of minutes. Like you can have the whole chaos in the system for the first time within 10 minutes. Yeah, so we can see that all the dependencies are getting installed, the charts, chaos charts, everything are getting installed. Experiments are getting installed, so it brings all the experiments. Then service account, cluster rule binding, so Litmus is getting installed here. And it will wait for a few seconds after that, just to get everything ready. Yeah, so now we can see we are getting the nodes in ready state, and yeah, so we are having a 3 node cluster setup with 2 worker node, one kind cluster, one control plane node on a kind cluster, and now so everything is configured. Your application is configured, so you just have to see whether all your application pods are coming in running state or not. So it might take some time for your system. It depends. It really depends on the resources you are having in your system. If it's quite large, then it will come in lesser time, and otherwise it will take some 2-3 minutes. And so this is the whole SockShap application microservices. So you can see that there are different. So there's one cards DB cards. So it is MongoDB actually database, catalog DB, front end orders and orders database, and the payment master, queue master. So this is a perfect microservice application on which you will get an opportunity to perform whatever chaos you want to see, and you can also visualize it in a number of ways. I will let you. I will go through that. So it will just take. So for my system, it's a little bit slow. Might take some minutes. Yeah, so we can see that Litmus chaos operator is running, which means Litmus is installed already. Yeah, so this is the front end pod which is running, which is in now running state. So we will just make a web UI look of the front end pod, whatever is there. So just taking the port of the deployment, front end deployment. So it will just give you the port on which port the front end deployment is running on. So yeah, so we get the port. Now we will just do a port forward to the deployment, and we will get one localhost IP with 3000 post, and we forwarded it to 3000. You just need to take this in the web UI, and we can see the SockShop application UI here. Yeah, so this is on this port. You can see the SockShop application is running, and it's handling connection for that. Yeah, so it will help us, like whatever experiments we are performing, whether it's killing up pods, or killing up the containers, or giving us memory or CPU spike to the containers, or the whole cluster in the whole node. So we can visualize it in one way, like what impact it is getting, our application is getting. So then that will be a good thing to see. So now the next step, so what we did till now, we listed the experiments, we get to know which experiments are available. We just through one command, and just the other command, the second command will just set up everything for you. And the third command will let you know, or let you run the experiments, whatever experiment you want to run. So like if you run just script with argument test without giving any flag, it will run all the available experiments which you get in the list, which you get from the list, doing list. So we don't want to run all the experiment right now. If you don't want to run, then just give a flag of test and give the name of the experiment which you want to run. Like if I want to run pod delete, then I will give just pod delete and execute. I will execute this step, and now it will set up everything for the pod delete experiment, and it will run the experiment on the SockShop application. And you will get the logs, and you will get the logs, experiment logs, results here only, and this is screen. Now we can keep a watch over the pods that is what's happening when a pod delete experiment is running. And at the same time, we can also keep a watch over our front end thing. So you can see that the pod delete, pod delete experiment pod comes up. This is the runner, the traditional thing which we do for running every experiment. So once this experiment pod comes, then it will create a helper pod which contains the main logic of the experiment. Like the helper pod will go and do a pod delete operation here to the given set of pods. Yeah, so we can see here it's cards DB application on which it is killing the replica, and we can just confirm it here, like whether it's what's effect it is having. So it might be good to run it for a longer period of time and just check it. So it won't have much effect on this because it's a front end application. Might be some database problem will occur here or whatever. So this is a way where we can explore more. Like this is the main purpose of having this litmus demo, to introduce yourself that with this chaos engineering stuff. You will just you can just run it for a higher duration, higher chaos duration, and can check what effect it is impacting on your application. Just not only pod delete, any experiment, what impact it is giving. Yeah. So once the application gets over, everything will get cleaned up automatically, and then sorry. So so this helps to take a view what happens as an experiment runs in this course. The pod may be killed, or the container may be restarted, or the resource usage may spike up, all impacting the application in just its own way. So yeah, now we can proceed to the end section, the cleanup section. So what we did till now, just three commands, and we have executed pod delete experiment. The first one, which is not actually mandatory one, so to run the list and getting the number of experiments, the name of experiments available. This started the experiment. This started. They started the setup with the start command. Just executed the experiment with test command, and now we can stop everything with the stop command. Cleanup. It's basically cleanup step. So you can see here, the stop it will delete the kind cluster from your system. Yeah. Yes. So we have successfully executed our first experiment by just running some 2-3 commands only, and introduced ourselves in the world of chaos engineering with Litmus in just few commands. So one thing which was left uh, I said you earlier that when you run the command, test command for pod delete. When we run the test command for the pod delete, I mentioned there that we will have the logs and results there. So that I wouldn't cover in here. I will just showing it in a separate video. So what will happen what happens when we run a pod delete experiment? So what it will show. So yeah, so the logs will show whether all the experiment details, like whether a pod delete experiment is getting created. So it's in getting state, and then when it gets created, the verbose log you will get about what is happening inside the experiment. This might be helpful in case of debugging or when you provide your own image, custom thing. Then at the last you will get the result where you will be getting the start time of the kiosk, the experiment, the name of the kiosk. So what is the status after all? So my kiosk experiment executed successfully. It gives a pass status, and the CardDB service is actually up and running after the kiosk. So my application survives this kiosk. So it's resilient to the system, to this kiosk experiment. And we have some kiosk result spec here also displaying, which will tell you that these things, that the phase is completed, the verdict is passed, and all the stuff. Yeah. So this is the whole process we just can follow to. Then some new guys in the community, I just heard in the starting. So the best way to start in this way. If you don't want to get into the documentations and everything, although that way is also very simple if you just dirty your hands a little bit with yours. So that's all from my side. Any questions?